Welcome to Tungalanal classes. Today we are going to start a new topic, moving charges and a magnetic field. Moving charges and magnetic field. In this moving charges and the magnetic field, we are going to study how the magnetic field is produced by the moving charges. How the magnetic field is produced by the moving charges. So what is the main theme of this topic is, so here moving charges are producing the magnetic field. Moving charges are producing the magnetic field. Before we are going to study how these moving charges are producing the magnetic field, let us discuss some basics what we studied in the previous classes. The first point is about the stationary charges. About the stationary charges. In this topic we are going to read actually about moving charges. Before going to study about the properties of the moving charges, once again we recall about the stationary charge. In electric field and charges first topic, we know about the charge. What is the charge? A charge is a fundamental property. A charge is fundamental property similar to that of the mass. A charge is a what? Fundamental property similar to that of the mass. And the next point is, if you consider the stationary charges, the stationary charges are producing the electric field. The stationary charges are producing the electric field around them. So if you consider any one of the stationary charge, around the stationary charge, electric field will be developed. And also we know the properties of the electric field also. That means when you consider the stationary charge at a point in the space, it is producing the electric field around it. Whenever some another charged particles are entered, into that region, those charged particles are experiencing the electrostatic force. Those charged particles are what? Experiencing the electrostatic force, or the electric field itself will exert some external force over the charges which are entered into the field. So that is the property of the main stationary charges. What is the main property? Whenever you consider the stationary charges, they will be producing the electric field, and this electric field will be exerting an external force over the charges which are entered into that region. This is about the property of the electric field. Now we are going to discuss about the magnetic field. So here simply the electric field is produced by the stationary charges, already we know. Now how the magnetic field is produced? In our common knowledge, we know that to produce the magnetic field, we need a bar magnet. To produce the bar magnet, what we need? A bar magnet. Without the bar magnet, can we produce the magnetic field? In generally we say no, because in our school section we studied about the magnetic field which is produced by the bar magnet. A bar magnet is having the two poles, one is the north pole and another one is the south pole. So according to our knowledge, we know that if you take any one of the bar magnet, that bar magnet will be producing what? Magnetic field. That bar magnet will be producing magnetic field around it. So here in the case of the electric field, this electric field will be exerting the force. Exerting the force on the charges which are entered into the electric field. But in the case of the magnetic field, this magnetic field is also exerting. Exerting magnetic force over the magnetic materials. According to our knowledge, what we know that once the magnetic field which is produced by the bar magnet into that region, if any one of the magnetic materials like cobalt, copper, nickel, like that, iron, okay. So whenever such type of magnetic materials are entered into the magnetic field which is produced by the bar magnet, they also experiences the magnetic force. So this is a basic information already we known. So electric field will be exerting the electrostatic force and the bar magnet will be exerting some external force over the magnetic materials only. Now coming to our topic now. So in our topic, what we are going to study? We are going to study the relation between moving charges and the magnetic field. How the magnetic field is produced by the moving charges. So this magnetic field which is produced by the moving charges is first invented by the scientist Oersted. Who was invented this one? The scientist Oersted. So the scientist Oersted, while he was giving the demonstration to his students in his laboratory, while the Oersted was giving the demonstration to his students in the laboratory, he noticed that a current carrying conductor will be there. Beside the current carrying conductor, a magnetic needle is also placed. Beside the current carrying conductor, what he was noticed? A magnetic needle is also placed. While the current is flowing through the current carrying conducting wire, he noticed that there was a deflection was produced in the magnetic needle. So he noticed that whenever current is flowing through the current carrying conductor, why this magnetic needle was deflected? So in generally, in the rotatory motion, what we studied in the first year, to rotate any one of the object, what we need? We have to apply some external torque. So here also, while the current is flowing through the current carrying conducting wire, he noticed that the magnetic needle was deflected. To deflect any one of the object, some external torque should be there. So this external torque or external force will be produced by some field only. This point is very important. Here, if you consider the electric field, it exerts some external force. Over the charged particles. If you consider the magnetic field, it is also exert some external force over the magnetic materials. Here also the same point we needed. So while the current is flowing through the current carrying conducting wire, the needle was deflected, means the needle itself, it is a magnetic substance. The needle is nothing but what? Magnetic substance. So here the needle was deflected, means over that needle, some magnetic force will be acting. So torque is nothing but what? Force into perpendicular distance. Here the needle was deflecting, means over the needle some torque will be there. If a torque will be existing, torque is nothing but force into perpendicular distance. If a force will be there, so automatically magnetic field is also there. So whenever the needle was deflected, it needs an external torque. External torque needs what? External force. If external force will be there, means what? According to the previous data, external magnetic field is also there. External magnetic field is also there. But here we told that magnetic field is produced by whom here? Bar magnet. In the previous case what we explained, the magnetic field is produced by whom here? Magnetic bar magnet. Bar magnet. So here there is no bar magnet will be there. Only current carrying conductor wire is there, as well as the needle will be there. So whenever the current is flowing through the conducting wire, needle was deflected means he confirmed that whenever the current is flowing through the current carrying conducting wire around the current carrying wire, magnetic field will be produced. This was first invented by the scientist. Oersted. So according to the Oersted principle, what we will define. So if you consider a straight current carrying conducting wire, around the current carrying conducting wire, magnetic field will be produced. How that a magnetic field will be produced? Suppose we assumed that the current carrying wire is placed along the positive z-axis. If you assume that the current carrying conducting wire, so vertically upward direction will be taken as a what? Positive z-axis. If the current carrying conducting wire was placed along the positive z-axis, around the current carrying conducting wire, magnetic field will be produced in a plane which is perpendicular to the plane in which the conductor was placed. Once again, how the magnetic field is produced? So if you assume the current carrying conducting wire is placed along the positive z-axis, around the current carrying conducting wire, magnetic field will be produced in a plane which is perpendicular to the direction of the current carrying wire. So to understand more easily, I am assuming that the current will be passing along the conductor along the z-axis, and the corresponding magnetic field will be produced along the xy plane, which is perpendicular to the z-axis. And one more point is that if you consider a straight current carrying conducting wire, so around the current carrying conducting wire, the magnetic lines of forces are formed in the form of a concentric circular loops. According to the Oersted principle, what he was told, if you take a straight current carrying conducting wire, around the current carrying conducting wire, magnetic field will be formed. Whenever the magnetic field will be there the magnetic lines of forces are also existing. So magnetic lines of forces also existing. How the magnetic lines of forces are existing means, if you take a straight current carrying conducting wire, around the current carrying conducting wire, the magnetic field lines are formed in the form of a concentric circular loops. So once the magnetic field lines will be there, how can we find the direction of the magnetic field? The direction of the magnetic field at a particular point is, at any point on the magnetic field lines, if you draw a tangent, that tangent will be giving the that a tangent will be giving the direction of the magnetic field at that respective point. So how can we find the direction of the magnetic field? If you want to find the direction of the magnetic field around the current carrying conducting wire, so first we have to draw the concentric circular loops over that concentric circular loops. At which point you need the magnetic field direction? At that point, if you draw a tangent, that tangent will be giving the direction of the magnetic field, at that particular point. So this is called Oersted principle. So what is the Oersted principle? According to the Oersted principle, if a current is flowing through a straight current carrying conducting wire around the current carrying conductor, magnetic field will be produced. This is about Oersted principle. Next one is, so what we discussed according to the Oersted principle, when you consider the straight current carrying conducting wire, around the current carrying conducting wire, magnetic field will be formed. To know the direction of the magnetic field, which is produced by the straight current carrying conductors, we are using one more rule, that is called what? Right hand thumb rule. So this right hand thumb rule can be used for which purpose? To know the direction of the magnetic field, which is produced by the straight current carrying conducting wires only. To know the direction of the magnetic field which is produced by the straight current carrying conductors only, we are using right hand thumb rule. Now, according to the right hand thumb rule, stretch your right hand. If you hold the current carrying conducting wire in your right hand, so the thumb is representing what? The thumb is representing the direction of the flow of the current. And the curling fingers are indicating the direction of the magnetic lines of forces. The curling fingers are indicating what? Direction of the magnetic lines of forces. Once again, so according to the right hand thumb rule, we are going to find the direction of the magnetic field, which is produced by the straight current carrying conducting wire. Suppose if you stretch your right hand, the thumb is representing what? The thumb is representing the direction of the flow of the current, and the curling fingers are indicating the direction of the magnetic lines of forces. If current is moving in the vertically upward direction, the curling fingers will be in the anti-clockwise direction. The curling fingers will be in which direction? Anti-clockwise direction. Suppose if a current will be flowing in the vertically downward direction. If a current is flowing in the vertically downward direction, see, the thumb is in vertically downward direction and the curling fingers will be in which direction? Along the clockwise direction, which will be giving the direction of the lines of forces. So, to know the direction of the magnetic field, which rule we have to follow? Always we have to follow right hand thumb rule. So, what is the statement of the right hand thumb rule? Stretch your right hand. The thumb is representing what? The thumb is representing direction of the current. Thumb is representing what? Direction of the current, and the curling fingers are indicating what? Direction of the magnetic lines of forces. If a current will be in the downward direction, curling fingers will be in the clockwise direction. If a current will be in the upward direction, curling fingers will be in the anti-clockwise direction. So, in this topic, we are using two symbols. which are very, very important while we are solving the numericals. So this cross mark is indicating that the direction of the magnetic field is acting into the plane of the paper. Whenever in your textbooks or in questions, if you find the cross symbol means, what is the cross symbol is denoting means? The cross symbol is denoting the direction of the magnetic field which is acting into the plane of the paper. Whenever the magnetic field is acting into the plane of the paper, you have to put the symbol cross mark. Next, dot. Here, the dot is representing that the direction of the magnetic field is out of the plane of the paper. Direction of the magnetic field is indicating what? Out of the magnetic field. In the previous case, the magnetic field will be acting into the plane of the paper. Whenever the dot symbol will be there, the magnetic field will be acting out of the plane of the paper. So, cross symbol is denoting what? The direction of the magnetic field is acting into the plane of the paper, and the dot symbol is denoting what? The magnetic field will be acting out of the plane of the paper. Now we will see how these symbols are used while we are solving the numericals. So in the case 1, I consider AB is a straight current carrying conductor. So which conductor I taken here? AB is one of the current carrying conductor. See in this direction. So here the current is flowing in which direction? Vertically upward direction. According to the right hand thumb rule, around the current carrying conductor, magnetic field will be formed, and the lines of forces are formed. In which direction? Anti-clockwise direction. If you consider a straight current carrying conducting wire, whenever the current is flowing in the vertically upward direction, the direction of the magnetic lines of force is what? Which are formed in anti-clockwise direction. Suppose for the same conductor, this is another conductor AB. So here current is flowing in vertically downward direction. So whenever the current is flowing in the vertically downward direction, magnetic lines of force are formed in which direction? Along the clockwise direction. So whenever the current is flowing in vertically downward direction, the magnetic field lines are formed in the form of a clockwise direction. Next, one more application. See here. So I consider AB is the current carrying conductor. Current carrying conductor. So whenever you consider AB is a current carrying conductor, according to the Oersted principle, around the current carrying conductor, magnetic field must be formed. So here I am assuming that this is a magnetic field region which is formed around the current carrying conducting wire. So in this magnetic field region, so if you consider a particular point, at that point, I want to find the direction of the magnetic field. So what we consider actually, I consider AB is the current carrying conductor and I is the amount of the current which is flowing through it. So whenever current is flowing through the current carrying conducting wire, according to the Oersted principle, so magnetic field will be produced. The magnetic field will be produced around the current carrying conducting wire. Now, at a distance of small d, I consider a point P which was present within the magnetic field. So around the current carrying conducting wire, magnetic field will be existed. So in that magnetic field, I consider P be the any one of the point. P be the any one of the point. Now, what was my aim? What was my aim? I want to find the direction of the magnetic field, at the point P, So here I want to calculate the direction of the magnetic field. Here I want to calculate what? Direction of the magnetic field. So already I told, to find the direction of the magnetic field, which rule we have to follow? Right hand thumb rule we have to follow. Which rule we have to follow? Right hand thumb rule. What is the right hand thumb rule again? Stretch your right hand. The thumb is representing the direction of the flow of the current, and the curling fingers are giving the direction of the magnetic field. Thumb is representing the direction of the current, as well as curling fingers are indicating the direction of the magnetic field. See here carefully. So I am placing my right hand thumb in the direction of the current. Here. So AB is the current carrying conducting wire. So my right hand thumb was placed in the direction of the current. Now, if I curl my fingers along the anti-clockwise direction, these curling fingers are moving into the plane of the paper. See, the thumb is placed along the direction of the current carrying conducting wire. The curling fingers are going inwards. Inwards means this the curling fingers are giving what? Direction of the lines of forces. So the direction of the lines of force is also giving the direction of the magnetic field. That means whenever the current is moving in the upward direction, when you place your right hand thumb, the curling fingers will be giving the direction of the magnetic field on the right side of the conductor. The magnetic field will be acting into the plane of the paper. Suppose I consider one more point Q on the left of the conductor. So on the right of the conductor, if you see, the magnetic field will be acting into the plane of the paper. It is a very, very important in the numericals. Just you place your right hand thumb along the direction of the current, and the curling fingers are giving the direction of the magnetic field. While you are curling the fingers, they will be acting into the plane of the paper. So that the into the plane of the paper means the corresponding symbol is a what? Cross mark. Now coming to here. So here again I am placing my right hand thumb in the direction of the flow of the current, Now curl the fingers, the curling fingers will be coming outwards. If you see properly, the curling fingers will be perpendicular to the plane. That means at the point Q, the direction of the magnetic field is out of the plane of the paper. At the point P, the direction of the magnetic field is what? Acting into the plane of the paper. Once again, this type of applications, so many applications we are solving in the numericals. It is very, very, very important. Just you put your right hand thumb in the direction of the current, and the curling fingers direction will be giving the direction of the magnetic field. On the right side, the field is acting inwards. On the left side, the field will be acting the outwards. So this is about right hand thumb rule. What is the use of the right hand thumb rule? The use of the right hand thumb rule is, it can be always to find the It can be always used to find the direction of the magnetic field, for which type of conductors. For which type of conductors means it can be applicable for straight current carrying conductors only. This is about Oersted principle and right hand thumb rule. Thank you.